All right. Good morning, everybody. So this is another edition of KETIV ABA. So my name is Grayson. I'll be your host today. For those of you that were here last week, I was also the host at this time, so they wanted me back again. For those of you that don't know me, I've been working here at KETIV for about, I think it's coming up on 6 years now. I've been on the delivery side, on customer success, and then now I'm working more on the consulting solutions. And then I'm joined today by Matt Bussey, who is one of our senior solution architects. And we're going to be talking about a topic that is very near and dear to my heart, virtual components inside of Autodesk Inventor. This is something that I've used in industry extensively. So when Matt was talking about bringing this up in the ABA, it was a very exciting thing to learn a little more about. As we move through this, feel free to ask questions. This is supposed to be an interactive and open event. If you have anything that comes up, go ahead and shoot off the questions into like the chat, and then myself or Matt will be answering those questions as we go through the event. But Matt, if you want to go ahead and take over.
Good morning, everyone. I'm Matt Bussey. As Grayson said, I'm a senior solution architect here at KETIV. Just a little bit of my background. For those of you who don't know, I'm an aerospace and mechanical engineer. I've worked as both, and also worked for Autodesk for quite a while on the Inventor development team and also in their customer services group. So got quite a bit of background in terms of Inventor and helping you all with the jobs that you do day to day. And virtual components are also near and dear to my heart. They're one of my favorite little things in Inventor. So just a little more about myself. Some of the stuff that I've been working on here at KETIV, just so you know, I tend to work on automation solutions. So things like full assembly generation, like simplified sales models and drawings, full detailed manufacturing models, and anything in between. So helping customers actually automate creation of their designs and their drawings. Another thing also near and dear to my heart in Inventor is sheet metal automation. Sheet metal in general, but some automation, things like adding a file name or part number to a flat pattern so you can etch it into the flat pattern in manufacturing later on. Generating DWGs and DXS flat patterns of, like, say, full assembly, full of sheet metal parts, so that you can generate a DXF or DWG package for your manufacturing group. So these are the types of things I typically work on. But today, as we mentioned, we're going to talk about virtual components. And so we're just going to break it into kind of two sections. First of all, stuff that some people know, but some people do know about virtual components, know some basics about it. But if you don't happen to know, what are virtual components, we'll talk about what they are, why they're used. We'll talk about how to create them, which can be very handy, of course. How to populate their properties, because virtual components tend to be used for things in bill of materials. So obviously you want properties for your bill of materials, your parts lists. And we'll go over a couple common questions about virtual components that come up. Then our second, we'll talk about stuff a lot of people don't know about virtual components, because there are things that virtual components do that I find that most, even Inventor users who even know that virtual components are there, don't know that they can do these things with virtual components. For example, reusing virtual components. No, I don't mean recreate, I mean reuse. Yes, you can reuse them, and quite easily. How to make virtual component quantities work the way you want to. And that'll become clear as we talk about some of their uses. Patterning virtual components. Yeah, you can pattern them. Isn't that exciting? Again, we'll show you an example of why you'd want to do that and how it helps you with VCs in your workflow. And then something that always comes up with virtual components, what about mask counts? Well, wait and see. So stuff some people know about virtual components, and stuff that you should know so that you know whether or not they're the right tool to use and when to use them. So what are virtual components, or VCs, as we'll sometimes abbreviate it? So they're a way to add a line item to a bill of materials without a part or an assembly file. So let me give you some typical use cases here. You'll typically use them for non-modeled line items, things that you don't actually create an Inventor part or an Inventor assembly for. So like paint, very common use for virtual components. Thread lock. If you're using Loctite or something like that, and you use it a lot in your assemblies that you're manufacturing, it does cost money. It's part of what has to be purchased in order to manufacture. So it's very common to have it as a line item on your parts list or your bill. Lubricant and grease, same thing. Hydraulic fluid, a lot of fluids, you don't tend to want to actually create a part file for them, but you want them included along with the volume or amount you have to purchase. Even things like software. So if I have a highly technical station that has custom software, it could come in different packages for some reason. And again, that could be something that's a catalog item that you want to have in your included bill of materials. You can add that virtual component to represent that software. So this is what virtual components were primarily meant to be used for, is things you don't model, but you want in your parts list and your bill of materials. So creating virtual components are very easy. When you're inside an assembly, you just click the create component command, just as if you're creating any other in-place component in an assembly. And when you're in that in-place component dialog, you give it a component name just like you normally would, but you click that virtual component checkbox over on the bottom right by the default BOM structure. When you do that, you're not going to pick a template because you're not creating a file. You're not going to pick the file location because, again, you're not creating a file. You just click OK. And when that happens, a virtual component is added to your browser just like any other occurrence in an assembly. It lives in that assembly in terms of the data, and there's no additional file on disk that you have to worry about. Okay? So, we have any questions on that so far that we need to answer, Grayson?
Actually, one just came in through David. Which Inventor versions have virtual components? And from what I'm aware, like it's always been something that's been incorporated inside Inventor, right?
Since Inventor 10, not 2010, yeah, 10. So any version
we're
of
going back a couple decades here.
Yes, we are. So virtual components have been there since the bill of materials capability was created for Inventor, and that did happen in Inventor 10. So they've always been there all along. This is why I say most people don't know that they even exist. They're not as well documented as I would personally like. And the use cases for them aren't as well known as I would like, but they can be very, very handy. And by the way, I'm sorry, go ahead.
Yeah, I was going to ask if there's another way that you'd be able to find virtual components inside of, say, Inventor versus just always through that create in place button. Is there like a, create virtual component outside of that?
No, there isn't. That's one of the reasons why most people don't find them very easily. Which is one of the reasons why we wanted to talk about them today, is to make it more well known of the fact that they're there. Now, whether or not you use them or should use them, those are different questions, obviously. But you can't use a tool if you don't know it's there. So this is where you find it. Okay. And by the way, Vault Professional with items will understand virtual components as well. We're not going to talk about that in any kind of detail today, but if you want to know more about that, definitely get in contact with us so we can work with you on that. Okay. Now, since they are meant to be a line item in a bill of materials and a parts list, they're not a lot of good unless you can populate the properties that also need to get filled in on that bill of materials. So it's pretty easy. Once you've created the virtual component in your assembly, you just right-click it and click on iProperties, just like you were trying to get to the iProperties of any assembly or part file. Okay. It'll bring up an iProperties dialog, just like you're used to with parts and assemblies. And you just fill in all your typical iProperties. It's got your project, your status, you can do custom stuff. And you can even do physical, which we'll talk about in just a minute. And once a virtual component is in your assembly, it'll show up in the bill of materials editor for assemblies, and you can edit them there as well. So like if you've got a bunch of virtual components that you need to edit all at once, you can do that from the BOM editor if you want to. See, we got another question that popped up.
Yeah, and this is an interesting one. So it's from Claudio, and he was asking, what's the difference between adding a virtual component versus putting a custom row inside of the parts list? And one of my immediate hangups about ever messing with a part list is because that's supposed to be a direct pull from the model. Like, you really don't want to be manipulating the parts list because that data isn't stored. Like, if you delete it for whatever reason, you need to repopulate it, all of that goes away. Most of all your manipulation needs to be happening from the bill of material level, which is exactly why you would want to use virtual components.
Right. So, and let me give you kind of a different take on that. As Grayson knows, I was intimately involved on the bill of materials with Inventor. And so this is the way we looked at it from the Autodesk side when I was working on this. The bill of materials is the single source of truth. The parts list is a report on the bill of materials. As a matter of fact, if you take Vault into account, this is where Vault never looks at the parts list on the drawing. It only looks at the bill of materials in the assembly. So the assembly should be the single source of truth. Now, part of the reason you can add extra lines on a parts list and you can modify parts lists separate from bill of materials, there's actually kind of two reasons. The first is that legacy. Before Inventor 10, BOM didn't exist in the assembly, and all you had were parts lists on drawings. So we had to give you the ability to create the parts lists you needed. Post bill of materials, the idea behind it was not only to maintain legacy compatibility, but it was also to give you the capability of, again, the parts list we see as a report generated from the BOM. Sometimes you have to manipulate the report to show what you need to show. Does that make sense to everyone? So really, especially if you're integrated with any kind of ERP or PLM system with Vault items, things like that, you really want to be using virtual components in the assembly BOM and not modifying the parts list on the drawing, because again, those systems will never see the parts list. They will only see the bill of materials in the assembly. Okay. All right. So I see a couple more questions that came up from.
So there's from Josiah. I think we're going to answer the quantities here in a second. The next one from Tim, that was a little curious about being a virtual part for child for multiple assemblies. I believe that'll be when we get to the reuse portion. So if you guys just hold on one second, we'll get there.
Exactly. So let's talk about some common virtual component questions besides those two, because those two are also common. Can I mix virtual components with real components? Yes, you can. This used to be more prominent and more relevant back in the 32-bit computer days, back when we had memory issues and we didn't want to put every single physical thing in a file. Like example, nuts, bolts, and washers. If you had hundreds and hundreds of the exact same bolt, the exact same nut, or exact same washer, that got really heavy in terms of graphics memory and in terms of computational memory. And so virtual components were used a lot back in the old days to reduce your memory requirements. Now with levels of detail, express mode, RAM being cheap, the ability to address more than 2 gigabytes of RAM, that's a less relevant reason to do this, but it absolutely still can be done. So that definitely. And again, we talked about this. Why would I mix them? A lot of it was a reduced model overhead while maintaining the detail for drawing documentation. That's a lot less relevant with LODs, but it can still come up.
This is actually the whole reason, at least in my last job, this is why we use virtual components. I worked in oil and gas, and we had to do pipe runs. So when you're getting into tube and pipe and trying to put bolting into that, it was a nightmare. We have to account for it somehow. And using virtual components was our first kind of exposure into that environment, and being able to put the correct quantities and making sure the bolts were accounted for without having to bog down each of our tube and pipe connections with bolting details.
Yep. Yeah, exactly. And I see Jim asked a similar question to Tim here. And Jim, we'll get your question in just a minute. Okay. Yep. So now another common question that comes up when you start thinking about, should I be using virtual components, is a virtual component better than an empty part file? Answer is, I don't know. The reality is that it's really up to you. of what makes the most sense. Now, again, virtual components, the primary reason for them was for line items for things you would never model. The secondary reason was for line items for things that you want to reduce in your assembly in terms of memory management and graphics management. But in theory, an empty part file pretty much does the same thing. So what's the trade-offs there? Well, really it comes down to, if you're using empty files, then you have to manage all those empty files, okay? Versus with virtual components, you don't have to. However, with empty part files, there is a slightly better reuse model than there is with virtual components. But again, we'll talk about virtual component reuse, and then it really is up to you and what makes the most sense for your workflow in your business, okay? So these are two pretty common questions. The third common question about mass we'll answer in just a minute. So getting this point, this is the stuff that most people know. A lot of people tend to ask questions for. Any questions up to any additional questions up to this point before we go into some of the really cool stuff with VCs? Ray, I'm going to answer that in just a minute. Matter of fact, I'm going to answer that next. So stuff a lot of people don't know about virtual components. Reusing a virtual component. Absolutely. Matter of fact, this was something that was a key. This was a key requirement on virtual components that honestly just didn't get documented well. It's really easy to reuse a virtual component. You just copy it and paste it. So once you've created a virtual component in an assembly, you can reuse it within the same assembly and between multiple assemblies. Now, because a virtual component does not have its own file, you can't just use a place command with it like you can with any part or assembly. So you find the virtual component that you want, you copy it, go to wherever you want it and paste it, and voila, it ends up there. So again, it can be within the same assembly, or it can be between different assemblies, okay? So one of the suggestions I make to people, and you'll see a kind of an example of this, a quick example I created for today's, is that I create an assembly file that only has virtual components in it, and it's all the virtual components I commonly reuse. And it's like my library of virtual components. Then I just go and cut, and so I create them, fill in the properties the way I want them, make sure they got the right part number, et cetera, and then I just copy and paste them to the assembly I want to actually use them in. Now, one of the notes, and you'll see this when I go through some of my examples later, is that when you copy and paste between assemblies, some of the things you can do with virtual components, also connect them to parameters in the file they're created in. It will copy those parameters over, but if those parameters have any equations in them, the equation will be thrown away, and you'll only get the value that it was evaluated at the time of copy. And again, I'll show you this explicitly when I go through these, okay? So, quantities. So let me explain that too, and then again, I'll show you an example here in just a minute. One of the things I tend to use virtual components for is hydraulic fluid, because I don't model it, but what I need is I need a volume that I'm providing with the system, okay? So in the example I'll show you, I'll have a hydraulic tank that has a maximum tank volume that I want filled with hydraulic fluid, okay? And I tend to set up something like a simple iLogic that updates an assembly parameter, because virtual components can only live in assemblies. My tank is a part file, so I'll do something in iLogic like I'll grab the tank volume and put it into an assembly parameter, and then I'll set up some kind of equations that are like, how much of the tank am I really filling up? You know, like down to 5% or up to 100%, and then that gives me the volume. And then I can hook that volume up to the quantity in the bill of materials properties for parts or for virtual components. So if those of you who have used base quantity in part and assembly files to set quantities to something besides each, like length or volume, virtual components also support that, but since they don't have their own file, you can only hook them up to the parameters in the assembly file that they are currently in, okay? And again, I'll show you an example of that in just a minute. And then in this example that I'll show you, like I even have it like putting in a percentage of the tank fill, because maybe I never fill the tank all the way full. Maybe it's only ever max 75% full or something like that. So any questions on this so far? And some of them, again, I might answer once we get to the examples showing how to do this.
Yeah, there is actually so Jim had a kind of follow-up question regarding the reuse of the virtual components. More, do you have to have, like, do you have to open up essentially the assembly or wherever those virtual components are to copy and paste them over? Or is a way to, can you get that information another way?
Out of the box with Inventor, yes, you have to open the assembly file that they live in to start the copy. With the Inventor API, you might be able to do other things, but I'd have to look into it. I haven't given it that much thought before. So,
okay. Now,
something I would love to be able to do someday through the Inventor API is to create like a virtual component gallery that you can just click on and it just insert them. But yeah, that's something for another day when I have some spare time.
Okay, yeah, something we could work on too. I mean, I would think that if you wanted to have a virtual component-esque part, no geometry, if you just wanted to maintain property information for the material, you could just create like a blank part and then be able to reference that multiple times.
Yes, absolutely. And there's nothing wrong with doing that. Like I said, virtual components are there for the convenience of your workflow. They're not the only way to solve the problem of having line item when you don't need geometry. Okay, empty parts work just as well for that. Okay, and I do say that I can hardly read my screen. Eduardo, sorry, my second screen is so far away I can't read it. Someone else asked a question about a template with iLogic.
Yeah, it was.
Yeah,
yep.
Absolutely.
Yeah, I just saw that pop up.
Yeah, absolutely. You can do that. The Inventor API supports the creation of virtual components. So you have to kind of use a little bit of mix of iLogic plus the Inventor API, but yeah, absolutely it can be done. And I've seen people online who have done that as one of the ways to create the reuse model, quote unquote. All right.
And then I'm not sure if we got to Tim's question, but as far as being a child for multiple assemblies, if I'm reading that right, it sounds like you'd have to have like that blank part that we were just kind of talking about. You wouldn't be able to use a virtual component or something like that.
Yeah, exactly. Virtual components don't have their own files, so they can't be children of other files. They can only be children of the file they currently live in. So when you copy and paste between assemblies, that technically creates a complete second copy, because it's defined. It's like you copy the definition from one file and you recreate the definition in another file. Is actually what's going on under the hood.
Mm-hmm.
Yeah, if you want them to be children of multiple files, an empty part is the best way to do it. All right. So one of the other things that's really cool about virtual components is they support patterning. Again, this was something where, since virtual components are meant to be a line item, but one of the original use cases was I'm not modeling all my bolts and nuts and washers. But it's really common to pattern bolts, nuts, and washers. And in this particular case, let's say I'm creating a hydraulic supply subsystem that has multiple tanks. Well, if I have my hydraulic fluid in my tank for one, and then I create a rectangular pattern, I just select the tanks and the virtual component for a fluid, and it copies that fluid too. So virtual components are supported in all patterning types, so feature, rectangular, and circular all support patterning virtual components. This makes calculating quantities so much easier, and the bit updates for the pattern updates. So like I said, if you need a total volume of fluid, or you need a total number of bolts and total number of washers, those totals are kept up to date with the patterning updates. Also, the mirror and the copy command inside of assembly. So when you do a mirror of components in assembly, or you do a copy of components in assembly, they also support virtual components as well. Okay. So
quick question for you, Matt.
Yeah.
When you pattern a virtual component, does does it treat each of those instances as a separate item, or if I change the properties in one, it changes for all of them?
Change it in one, changes for all of them. It's a component.
Okay,
So from the standpoint of behaving like a part file, think of it as a part file without a file on disk. Does that make sense? So if you change it for one, it changes it for all, but only in the context of the assembly you're doing the editing.
Okay.
Does that make sense?
That makes sense. Yeah,
Okay.
I was curious if it, if it would follow kind of the rules of a part, even if we were in, say, like a pattern or mirror copy. I know there's some workflows you can kind of get into, so you can kind of disassociate those. So maybe can you like remove association from a pattern and then be able to create, like, modify that part?
No, okay. Unfortunately you can't. And there's nothing directly to do like a component replace with copy.
Okay.
So the copy only copies the occurrence, not the definition, is the way we talk about it internally in Inventor and as an API developer. But a copy and paste basically works the same way as a part copy and paste. You're just creating another occurrence of the same part. Does that make sense?
Yep. Brian had a question come in about if the virtual component becomes hidden from the assembly after you do the pattern.
No. Well, it depends on what you mean by hidden. If you mean hidden in the same way that any other part file gets consumed inside the component pattern browser node, the answer is yes. But it still can be reused and copy and pasted independently, just like any other part or assembly. Does that make sense, Brian? Yes, it's consumed with the pattern. Yes, it is. Okay. So what about mass calculations? Oh, this one always breaks my heart, unfortunately. I so want this to be more than it is, but it is what it is. Can virtual components have mass? The answer is yes. So the first thing you have to do is you have to go into the I properties, go to the physical tab, and you can assign a material. Okay. And when you assign the material, that's great, but it has no volume because it has no geometry. So you can manually type in a volume in the dialog, and then it will calculate a mass based on that manually typed in volume and the density of the material you'll give it. So it does give a mass, and that mass is added to the assembly mass when you update the mass for the assembly. However, the assembly mass calculations don't take into account virtual components when they're calculating the center of gravity. So the polite way of saying this is the center of gravity can be inaccurate with virtual components. The way I would put it is it will always be wrong with virtual components. The reason is this: the way the center of gravity is calculated is it's calculated using the Autodesk Shape Manager, which is the modeling kernel at the heart of Inventor. There is no geometry for us to calculate the mass volume and its moment of inertias and principal moments and all that stuff. So the ASM kernel can't take virtual components into account when calculating the COG because there's no geometry there to account for. So unfortunately, if you're like your hydraulic fluid, things like that, if you need to have them for COG calculations, you must model them. Okay.
Okay. So we had a question come in from Will about using transient geometry.
No, it won't take, if I remember correctly, and I could be wrong on this because I've never really looked at it closely, I do not believe ASM takes transient geometry into account for mass calcs. It only takes into account actual resultant solid bodies.
Okay. Okay. So even sketchwork isn't going to be considered a geometry-based feature inside of Inventor. It's got to be like a parametric solid.
Yeah, because it doesn't take into account open surfaces that don't hold water. Matter of fact, it doesn't even take into account surfaces that do hold water that haven't been converted into a solid, if I remember correctly. Like I said, we're getting into some sketchy areas of what I remember and don't remember about the underlying innards of Inventor, but yeah, unfortunately it's got to be rendered as a solid in order for ASM to really understand it to do COG counts. So someday I'm hoping they update this so you can actually at least position the virtual component somewhere, and maybe at that point it would pseudo participate in COGs. But for now, if you need a good accurate COG, model everything. That's your only alternative in Inventor at the moment. Or do a whole lot of math by hand, which I know I'm not going to do. All right, unless there's any other questions, let me do a few quick demos, kind of showing you just the basics of the things we've talked about. Does that sound good to everyone? All right, so give me a moment. I've got to switch over to sharing my Inventor screen. So first of all, let's talk about actually just creating virtual components. So you see here, I have an example virtual component library that I've created. This is just an assembly file that just holds the virtual components I want to use and reuse. So I'm going to add another hydraulic oil here. I got to get up here what I want. So I'll create a new component. And what I'm going to be creating here is just another mobile DTE product. I used to use many years ago when I was a real engineer for my design. So mobile DTE 10 XL5. I'm going to add it as a virtual component. So give it the name, click virtual components, click OK. Now I'll drag and drop this into my hydraulic oil folder just so I have it. Now, in this particular case, I'll need to fill in its I properties. Now, I tend to buy this off of McMaster Car. So I want the McMaster Car part number for it in here. So give me that, and I'll give it the web link for the McMaster Car just so I can find it. I'll put in a description for it. And, I will normally fill out other things as well, what I want to do. I'll go ahead and set the physical properties of this right now. I happen to already have that hydraulic fluid already set up with a density, okay, what I want. Go ahead and click OK. So now I've got it and I'm ready to use it. So now if I go over to my hydraulic supply here, now I already have the DTE 26 in here, so I'm going to get rid of that for the moment. So if I want the DT 1015, I'm going to copy that. Right click and I'm going to paste it. So there it is, already set up. Okay, in my bill of materials. Come over here to my, let's turn my structure on here, enable it. All right. Now I haven't set up its quantity yet. Okay, so I need to get that all set up. So if I come in here, let me look at my parameters here for a moment. You notice I've got some parameters here: hydraulic volume for analysis, hydraulic fluid quantity max, things like that. There's a few things that I can do here because, like, one of the things I used to have to do is I used to have to do some basic mass calculations. And so I may do different mass calculations for different percentages of how much I'm going to fill it up. I'm not going to show you that today, but it's all possible. But this hydrofluid quantity max is what I want to have as my quantity for my fluid. Now I have to go in here and change this real quick. Let me copy that name. I'm going to update this name. So in here, I got a simple little iLogic script that grabs the max volume from the tank, allows me to set my percentages to the high or low if I want to for my analysis or not. Oops. What did I mess up? Oops. I may have to fix this part of it later. All right, I'll save that for later. But if I go into my component settings, I can then change my base quantity to be hydraulic fluid that I want and set it. Now my bill of materials, I've got 48 gallons as my quantity for my fluid. Okay, any questions on any of that? pretty simple. Like I said, I'll have to go in and figure out what I broke with my electric script for later. So that's one thing. Another thing that I wanted to show you all is, again, patterning. So one of the common things I used to do when I had hydraulic systems that I was working on that might have a lot of flanges in them, and it's pretty common for us to have to do a detailed view of one flange showing all the bolt rings, but I don't, but only one. And I may have dozens of flanges where I'm in the drawing, and you know, when you're back here, you can't tell whether or not there's a bolt in there. So I only need it for my up close detail view in one drawing view. So I would come in and I would actually put a bolted connection in and feature pattern it on one of the flanges. But you notice here, I have my virtual components that I created that match the elements of my bolted connection, the circular washer, the helical springs, the bolt itself, the nut itself, okay? They actually match the part numbers that are in there. So if I come in here to my bill of materials, you can already see things are promoted, okay? So when I come in and if I wanted to pattern these based on the other feature patterns of other flanges, I would just come in and select all the components I wanted to copy, then do a feature pattern there, grab that circular pattern, and it would update all of those. You see 16 updated ones.
That's interesting.
All of the
Okay.
ones. Even my quantities all today.
Yeah, because that's actually a pretty cool workflow. I'm trying to think back when all those typing the bolt, and we would have a chart and we just have to manually change the quantity of the virtual component inside of the bill of material. Like, you know, if you've got a 4-inch, 600-pound pressure class flange, I mean, it's got X amount of bolts, and we just have to copy and paste essentially. So that pattern on the features is really interesting.
Yeah, I'm not doing that much work. But yeah, this is one of the unfortunate things about virtual components, that people don't know you can do this, and you absolutely can. And it's really, really cool. And like I said, for mirroring and for copying, it also works. So again, if I want to come in and I want to, let's say I wanted to create a mirror of all of these things, I come in. Now, virtual components, when you do a mirror copy, they are automatically reused. They're not, because you can't physically mirror them, okay? So that's just something just to be aware of. But that's okay. I don't need to mirror them. You know, it'll do things like mirror relationships. I actually don't have a mirror plane in here, so I forgot to set one up. But you know, you just click on a mirror plane and you select the mirror plane, and then it just copies everything over. Okay? So yeah, all your patterning, all your mirroring, all your copying for assembly components all work on virtual components. And again, the whole idea behind it is to make it easier to use them, to keep your quantities up to date and keep your bill of materials accurate. Okay? So in terms of demonstration, those are the things I wanted to demonstrate most for all of you. If there's something else you'd like to see, you want to stump the professor, ask it real quick in the last couple of minutes. So Jim,
one question that came through, yeah.
Yes, the real components and the virtual components are combined. There's a little bug going on here. I got to figure out what's going on because I'm getting quantities more than I know I should. I think it's because there's something funny in the bolted connection that I accidentally did. Oh, no, I know what it is. It's because the bolted connection I actually showed. Now, so here's one of the things you do have to be aware of where you may have to manually manipulate virtual components. In my real bolted connection, I'm actually using the same washer twice and the same lock washer twice, and that's not currently happening with the virtual components. So the way I would have to deal with that is this. So since I have actually 2 instances of each washer, I would do this. I grab the regular washer, come on, drag and drop. Create copy, drag another washer, copy. I'm glad I remembered to show you this because I meant to show you this. Now, when I do my pattern, I select all of these, then do the feature pattern there. There we go. Now those quantities should look, yeah, that's looking better. Yeah, that's what I'm expecting it to show. That looks right. Okay. So keep that in mind with virtual components is that, if you're using more than one copy of the same component, like say in a stack up, make sure your virtual component matches that stack up in terms of the number of virtual component instances that you have in your browser before you do your patterning. Okay. All right. Do we have any other questions while I switch back over to my slideshow here?
No, there's just a couple I just answered through the chat, just around like possible workflows and things. I think that's everything open for right now.
Okay. So before we wrap up, do we have any other questions? Do we have any other questions that we got asked that I haven't had a chance to answer yet? I don't have a question thing in front of me. So, or if there are any new questions, please go ahead and ask. Try to stump the professor.
Can virtual components be part of a template? That's
Absolutely,
interesting. So if
yes.
you had like a template assembly, you could put virtual components in there and just have them pre-stored.
Absolutely. However, remember, if they're in the template, they'll be in what you create from the template, and they will be in that whatever you created's bill of materials. So that's why I usually create a file that is its own library and I copy and paste in. Because if you have them in the template, they are in the bill of materials, which means you have to remember to delete the ones you don't want. And this is why, like I say, one of my desires in life, when I find a few minutes, is to figure out a way of hooking that library up to some kind of little graphical thing on the ribbon bar, so you can just insert them from there. That would be really cool. But yeah. But in the meantime, yeah, just when I tended to do it, I would create that assembly file. I would put it in my libraries folder, and then I could just open it from the libraries folder and then copy and paste from there. So, and then people didn't muck with it who weren't supposed to muck with it. Not that they can't muck with it once they paste it into their own assemblies. They can. There's no way around that. But they'd be doing that anyways if they're creating their own virtual components. So
yeah, and it's another thing too. I like to point out, if you want to library virtual components, another way of handling it, of course, is making a component or a part that doesn't have any geometry. Yep. And placing that into the content center. Like, you don't have to have geometry to publish the content center. If you have, say, like bolting kits, like we were just showing on the flanges, you can go ahead and store all that information in the content center. And then as a designer or an engineer, when I need to have that information incorporated into my design, I can easily place it through that functionality versus having to go open up a different assembly and copy paste some parts over. So there's a few different workflows that you can kind of get into here with that.
So again, the thing to remember is that virtual components are meant to be a tool in your toolbox. They're meant to be a line item in your bill of materials without having a file, but that's not always the right thing to do. There's nothing wrong with having empty part files. There's nothing wrong with having part files with simplified geometry. What's going to work best for your workflow and your business requirements, that's what you should do. The primary reason for us showing you this is to make sure that you have yet one more tool in your toolkit to get your job done as efficiently as possible.
Yeah, and to that point, I've had quite a few questions come through here on workflows and some pretty particular questions on just like, hey, how can we implement something like this? That's really, why we're here. If you have questions on how to best implement this kind of practice, be it empty components, virtual components, or whatever you want, feel free to reach out to us and we can help you figure that out.
Yep. All right. Unless we've got any more questions, I think we are wrapped up. And Nigel would be proud of me. I finally got an AVA done in less than an hour.
I think this will be my shortest one yet. No, I think that's it for everybody. I have any more questions come through, and thank you, Matt, for putting this on. This is a great topic.
Absolutely, my pleasure.